In this component of the PPST, we'll look at some common algorithms for rational number operations. For example, you might recall when we add two rational numbers as fractions, we must find a common denominator. Therefore, to add 5/8 and 3/4, we need to find a common denominator, which is 8. We know that 3/4 is 6/8, so now I have 5/8 plus 6/8, and I want to know how many eighths I have. Well, in the algorithm, we take and we add our numerators, which would give us a total of 11 eighths. In order to add and subtract rational numbers as decimals, we're going to line the place value. Therefore, 32.07 minus 4.296, we would line our decimal place, which aligns all our place values, and then we would use the standard algorithm for subtraction. In order to multiply or divide fractions, we have rules as well. To multiply, we're going to multiply numerators and multiply the denominators. Therefore, 3/4 times 1/3 is the same as 3 times 1 divided by 4 times 3, which is 3/12, which can be reduced to 1/4. Sometimes estimation is a little bit quicker on the PPST, and we can use benchmark fractions. 1121 is about 11/22, which is about a half, and 31/120 is about 30 over 120, which is a 1/4, so our product can be estimated as 1/2 times 1/4, or 1/8. To multiply decimals, we can change them into their fraction form. We have 4/10 and 52 hundredths. And in order to multiply these, we would multiply the numerators 4 times 52, which is 208, and 10 times 100, which is 1,000. Notice that when we want to convert this back into decimal form, dividing by 1,000 moves that decimal place 3 places to the left, which is the same as summing the number of decimal places in each one of our factors. We can also use estimation or benchmarks in order to estimate our answer. We could estimate this as 0.4 times 0.5, which is 2/10, which is a very close estimation. In order to divide fractions, we are taking a dividend in our divisor, and we're asking ourselves, how many times can 2/3 fit into 1 3/4? If I have 1 3/4, I can see I can fit a little over 2/3 into 1 3/4. Our standard algorithm for multiplication says we take our dividend and we multiply it by the reciprocal or the inverse of our divisor. Therefore, 1 3/4 divided by 2/3. 1 3/4 as an improper fraction is 7/4. The reciprocal of 2/3 is 3/2. Therefore, we would take 7/2 times 7/4 times 3/2, which gives us 21/8, and 21/8 can be rewritten as 2 5/8. To to divide decimals, we can divide them as if they were fractions. So I have 3 2/10, or 32/10, divided by 4/10. In order to divide, I can multiply by the reciprocal of my divisor. Therefore, I have 32/10 times 10/4, which gives me 32 divided by 4, or 8. Again, we ask ourselves, how many times can I repeatedly subtract 0.4 from 3.2? Estimation allows us to do some quick computations on the PPST. For example, if I want to find the product of 42 and 159, I could estimate this as 40 times 160, which is the same as 40 times 100 plus 40 times 60, which is 4,000 plus 2,400, or 6,400. I could use benchmarks in order to estimate sums and products with decimals and fractions. For example, 9/37 is about 1/4, 17/33 is about a half, and 11/12 is really close to 1. Therefore, my sum is very close to 1/4 plus 1/2, which is 3/4 plus 1, or 1 3/4. For the product with decimals, I can estimate 0.48 as about a half, 0.17 is about 0.2, or a fifth, and 38 is about 40. Therefore, my estimation is 1/2 times 1/5, which is 1/10, and 1/10 times 40 is 40/10, and 40/10 is equal to 4. Therefore, my product is about 4.